All right, so I'm going to be talking about some industrial application of a range of emerging tech that also includes AI, and really focusing on what are some of the benefits that enterprise have gained from those the application of those technologies, and also looking at it from kind of a human factor perspective. So I would start off with some of the technology that I've been playing with, including wearable tech. Sorry, are you all able to see? Yeah. So vision-based picking has been used by DHL, and allows them to save 25% increase in productivity just by the fact of having the information that you need aligned in your line of sight. So that's already in use in warehouse logistics and already delivering some benefit. There's been quite a lot of use of those technology also in the manufacturing and training sector, where having the information needed in your line of sight has led to an increase on productivity by 33%, and also a major decrease in errors. And that's an interesting bit. This is work that I've done with Boeing, where GE Digital reported 1% improvement in aircraft engine maintenance efficiency can reduce cost by 250 million annually. So any gain in this sector, even if it's just 1% gain, can actually really deliver some huge benefit. AI also has been used for wiring harness assembly solutions and has cut the production time by 25%. This is another example of the use of augmenting the vision, and this is done by Mini, and it has been used to eliminate blind spot, to display the speed of limits on the screen, and basically providing step-by-step navigation, so that instead of listening or looking at your screen, you actually have it on the one screen. So it shows that the primary market for this type of technology is the enterprise. Over 60% of all the smart glasses are actually used for commercial and industrial purposes. So you may ask, where is the SME who comes in here? Well, this technology is also changing the way we collaborate in the enterprise. And one of the big challenges that SME have is when, for example, they deliver maintenance or engineering services to, let's say, mine sites, is the issue of trying to do more with less resources. Because if they send the expert to the site, then they can't service other needs. So here is an example of how this technology has been used in order to enable a more innovative way of delivering those services at a distance. Remote technology is a technology that allows a remote expert to assist in real time a field worker anywhere, anytime. All you need is an internet connection. So instead of calling the expert and trying to get their assistance over the phone, or instead of flying in the expert, and that costs a lot to remote operation, you click a button and you have instant communication with your specialist. You're able to demonstrate with your hand what needs to be done. You know, what particular way you need to turn, for example, a knob.
Can you please use your touch to show me the side of the machine? There should be 3 connectors there.
Remote technology is a technology that allows a remote expert to assist in real time a field worker anywhere, anytime. All you need is an internet connection.
Okay,
so instead of calling the expert, we initially designed it for the mining industry, but we also have, instead of flying in the expert, and that just have a head-mounted system that you can adjust a button the way you want it, whether you can with your prescription glasses, so you're able to demonstrate with your hand what needs to be done. You know, what particular way you need to turn, for example.
Also, the expert can.
My apologies. There's been some issues with this video. Don't understand what's happening. It was working prior to my presentation. industry, but we also have a different form factor that allows you to just have a head-mounted system that you can adjust the way you want it, whether you're wearing prescription glasses, safety glasses, or whatever.
The worker is seeing, in addition to the gesture of the expert, also the expert can worker can tags documents to retrieve information like workspace, technical documents, manuals, annotations, videos.
There is a wide range of applications for this technology, and the industry that would benefit from it include health, transport, mining, shipping. Okay, my apologies for this video. It's not working, but I hope that gives you a gist of what this is enabling. Is really enabling different ways of delivering services where you can actually do it just in time. And the real innovation is not necessarily the fact that it's hands-free and it's intuitive to use. The real innovation is around the fact that the SMEs that deliver the services to those remote sites can actually provide a value-based service. And so if a particular asset needs to be addressed and very quickly, they can actually charge a much higher price. But then they also could be able to negotiate a way of pricing the service there, depending on the value of the asset. What we see is that it's beyond productivity gain. It's actually also reducing the cognitive load and increasing the learning on the job. Reducing the cognitive load because you're not constantly having to get the information you need and then translate it in the space where you need to operate. You have it all in situ and in your line of sight. So the real value for the client is to increase productivity and decreasing equipment downtime, and that is a huge value. But it's also in terms of upskilling the workforce. As we know, in some industries, quite a lot of people are retiring early, and that expertise is lost. So how can you bring that back in the site? Also, this type of technology also allows you to integrate different functions like inspection and maintenance, and always have someone who can actually audit what has been done. This is another video that showcased what could be done in 3D. So while the whole value of this is actually bringing the hand of the expert in the workplace, 2D limits the perception of that space. So this is an example of how we're allowing to bring that remote operation to the expert and allow them to be fully immersed in this environment and be able to see it from different perspectives, but also guiding in 3D. That means their hands are in that remote workplace and are able to go beyond the object, in between objects, to the full spatial awareness. So imagine if now you need to be guiding someone to do something very delicate, very dangerous, and you need to be super specific about how the operation, the procedure needs to be taking place. This is basically enabled by real-time capture of the remote space, but also real-time capture of the hand of the specialist, and allowing the overlay between the two. This is another example where we're actually augmenting the virtual space. So therefore, the two people that are in the two different places are working in a totally digital place, virtual place, but we're allowing them to use their hands in order to move virtual objects, so that they can co-create together, or they could be a case for remote guidance as well. I'm just going to quickly show you this video, and I'll just get to So here what is happening is that the hands are being tracked, and you are able to basically work with someone and co-create together. So in this example, we were working on a 3D puzzle just to do the study. But you can imagine also in a digital training scenario how this could be used. So basically, why I'm sharing those type of video with you is to show where things are going with this next wave of computing, where while we think and work specially, yet we design our tools in 2D. So the real value in actually moving in real time 3D is making the world our UI. So and therefore and using our body as the input device, and this is where natural user interaction and multimodal interaction are important. And there's also scientific evidence that when you use your hand in manipulating objects, you actually think and collaborate better. So this is where what technology is enabling now is really about allowing us to take the full advantage of the ergonomy of our brain. And this is where we bring in 2D and 3D, but also mixing the virtual with the digital. And that is the next generation of computing, where we're merging the digital with the physical, whether we're augmenting the physical space with digital, or whether we're augmenting the digital space with a 3D capture of the physical space. We are literally bringing them together, and we're enabling creating those cyberspace where people are interacting as if they were co-located. But mostly, it's actually really opening up the bandwidth in terms of interaction, because we're enabling rich, embodied experiences with this natural user interaction, as you've seen in some in the video, where people are using their hands naturally and their body to change their perspective. And this is one space in which the next generation of computing is moving to, that will really change the way we work, but also the way we collaborate. The next part is going to be focusing on wearable technologies, but also and the role that AR plays in that space. So some of you may have heard about the concept of Internet of cows, where people have put sensors on cows in order to help predict the milk production. I am going to talk mostly about the use of wearable sensors to help with safety. So this is a project I undertaken 2 or 3 years ago with the ThoughtWorks, where the key issue was truck driver fatigue. They would drive over 6 hours, 6 to 8 hours shift and get tired, and that as they get drowsy, their safety is at stake. So this project is called Smartcap. It's a startup in Brisbane, and basically what we were doing here is capturing EEG signal from the brain, and using some clever sleep theory and clever analytics, able to predict macro sleeps. And the beauty of predicting macro sleeps is that you become aware of your fatigue before you actually start blinking your eyes. So someone today was talking about the invisible. So this is something around making the invisible visible. If you wait until you start blinking your eyes, it might be a bit too late, and you may have a much shorter time frame for responding. Whereas here, you're actually really able to predict the occurrence of macro sleep and act accordingly and stay safe. So one of the interests of mine from the startup that I'm running is really along the line of this making the invisible visible, and it's in the health space. So what if we could monitor our wellness and detect disease at the much earliest stage possible before we experience the symptoms? Along the line of this fatigue application that I mentioned. Maybe a serious disease is growing, and it could be striking us anytime without any warning. How can we actually detect those type of things? What if we have the ability to hack ourselves towards increased resilience and health? So one of the things I've been looking at with my startups is the issue of chronic stress, because chronic stress is actually really a silent killer. It has a huge impact on the immune system. connects with chronic inflammation, and we know that chronic inflammation also leads to chronic disease. It also damages the cell, and one of the risk factors is actually an increased fat in the abdomen. And I'm not talking about the stress that is really more around, a positive stress. It keeps you motivated and focused. I'm really talking about the chronic one, the one where really you start having some exhaustion, burnout, and so forth. And this is something that really is becoming more and more prevalent in our society, unfortunately. So what I have been looking at is the work by this institute called HeartMath, where they have looked at heart rate variability as a marker of resilience to stress, and also as a biomarker of aging. So basically, we're talking about heart rate variability, not heart rate by itself. So the more variation you have, the higher, the better it is, the more resilient you are to stress. The less variation you have in your heart rate, the less resilient you are. And what they have done is really 25 years of scientific research on stress, emotion, and the effect of heart activity on the brain. And this advances in understanding our heart and how to bring it in harmony with our brain is really a key to health prevention. So I've been drawing on this work in my startups to allow the continuous monitoring and self-regulation of the stressor, one stressor at a time. So basically what it's doing is monitoring HRV, allow you to input your stressor that you've identified, and through some clever analytics and regulation, you can provide some biofeedback in order to allow your system to build resilience. For any further information, I've put in the link here. So basically, it's integrating mobile with wearable. It's using data analytics, and it's not just about monitoring. Don't think about it as just jumping on the scale, but it's also about allowing that biofeedback. So when we have a deeper understanding of how our body functions, if we can monitor something that is not visible and also use it as a way to be in sync with our heart and brain, which increase our resilience, then we'll have this continuous self-regulation. So that's something that really fascinates me and interests me. Now, just with the time that I have remaining, what
just 1 minute, Leila.
Those examples are showing is that this next wave of computing is going to be enabling new ways of working, but also new ways of being. It allows to create a more natural and close relationship between human and technology. And this is enabling ways of collaborating, but also ways of living and looking after yourself. So we looked at the spatial computing and how we're integrating those both digital and physical. We looked at applications that are more responsive to our internal mental states with the fatigue as well as the stress. These are things that are going to be evolving with us, but also will give us agency in terms of managing our health and well-being and allow us to work more effectively. And I guess that's, I will finish on this note. And these are some of the books that were written around this. There's a stronger and stronger interest in those type of technology, but also what it means in using them in not only unlocking value from them, but enabling innovation in the digital economy. And on this note, I will thank you.